So, good evening and good morning to Dr. Praveen. Hello, everyone, and welcome to today's webinar. Attendees and presenter, Dr. Praveen Dubey. I would like to introduce in short that he is a global R&D metabolism scientist at FMC, Stein Research Center, Newark, Delaware, and USA. He is very prolific writer and also orator that you will feel when he will present his topic. And today's topic for the webinar is insect sex pheromones, an important tool in IPM, that is integrated pest management. In fact, pheromones are generally produced by female insects and then they attract. But in IPM, pheromones are used in different ways. And these ways could be trap catch, killing through mass, trapping, mating disruption. All these are the, and also in some cases as attracticide, that is to lure and then kill them. So this is the short, and the basic concept of the IPM lies on the fact that no single approach could be used for the pest control offer as a universal solution. With this brief introduction, I welcome Dr. Praveen Dubey, and on behalf of Dolphin Postgraduate Institute of Biomedical and Natural Sciences, Dehradun, request Dr. Praveen Dubey for webinar continuance. Now over to Praveen Dubey ji.
Good afternoon, and everybody. Thanks, Dr. Pandey, for giving me a good my background and what is the topic today. So I would like to start my presentation. So as Dr. Pandey told that my topic is insect sex pheromones, an important tool in IPM, and he also gives some idea about what is IPM. In this slide, before moving forward, I want to give my small introduction, my academic background and professional background. So, my academic background is I did my BSc, just like in we called biology group in Bachelor of Science. So, I did from Buddha PG College, Kushinagar in Uttar Pradesh, and then I joined MSc and PhD from GV Pant University of Agriculture and Technology with the major agrochemicals. It seems is belongs to the agriculture, but my department in the basic sciences and is belong to the chemistry department. In the PhD, my minor in also entomology. That is the agriculture field because my work also related to the same field, insect sex pheromones. So I have to know about the agriculture also, especially the insect on which I'm going to work. So sorry. So I did my PhD, and then I joined Indian Agriculture Research Institute as a research associate in the same department, same division. There's agrochemicals. So this is my academic background, and then I joined my professional background. Start uh, from GRF. It's called J Research Foundation. This is the contract research organization situated in Vapi, Gujarat, and where I met with Dr. Pandey, uh, and he was already there. After that, I moved to GRF America in Pennsylvania in US and working as a group leader in the field of residue chemistry. After working there, I moved in a different state. It's called the Massachusetts as a senior research scientist. But my work little bit changed from pesticide residue to environmental fate and metabolism, where most of the studies conducted with the use of the radio level test compounds. And here we work especially that how the what is the fate and how the pesticides metabolite in the environment. just like the different compartments of the environment, like soil, sediment, water, plant, everything. And I just recently joined the FMC. He's the top leader in the pesticide industry. He's called the FMC, and I joined in their research center. But my role now is the regulatory part of view. So I'm totally focusing on the data which is generated for the restriction of the pesticides in all over the world. So we totally follow the guideline, which is just like US EPA or EU guideline or Australian or Japanese, where the product needs to be registered. And here the picture at the bottom, you can see where the FMC Stein Research Center. So you can see just like east coast of the US, and there is one state is called the Delaware, and you can see just like in the some close up here. So you can see that's my background, especially in the pesticides from beginning and till now. Still, I'm working in the same field. Uh, it's good for me. At least I'm the same streamline. Okay, now I'm going to move our topic. So what I'm going to cover in today's presentation, what is the IPM? Dr. Pandey already gave some introduction about that. Second is the pheromones, where it stands, and chemical signals, because pheromones, especially the communicated by the chemicals, and then the what are the insect sex pheromones? What is the history? I'm going to talk. We have a very long history, but I'm not going to take much time to describe each and every point. I'm going to describe only the major milestones, what happened in this field, and little bit chemistry, not going the more details, but at least I have to describe that how the molecules and how it works. What are the characteristics of the pheromones? How we can analyze if we want to analyze, and what is the practical application? This is the main thing where I want to focus. And what is the advantage, and what is the global market scenario for these pheromones, and what is the regulatory requirement? So these are the points I'm going to cover uh, further. So this is the insect pest management as per US EPA definition. Integrated pest management, that is IPM, is an effective and environmentally sensitive approach to pest management that relies on the combination of the common sense practices. So in this case, you can see that this is not only one practice we have to apply, because suppose the one example, we are going to kill the pest by pesticides. So that also going to accumulate in the nature and give that lot of environmental problems. So we have to think, okay, how we can minimize the chemicals in the nature. So you can see at the bottom the different practices is mentioned here, just like physical and mechanical practice, biological practice, chemical and cultural. So we can use all these practices to minimize the use of the chemicals, but the proper control of the pests. And the pheromones is belong to the biological agents here. So pheromone is the part of the biologicals. So as I told that pheromones is the chemicals, and the chemical signals were the first type of the communication that involved on the earth, uh, especially because we test the food and smell the food. That is because of the molecules what released from that source, and we inhale or we smell that one. So these type of the chemicals is called semiochemicals or behavioral modified chemicals or chemical mediators, infochemicals. But if you go on the literature, the semiochemicals terminology using a lot rather than the bottom three. So most of the time you see the terminology semiochemicals when they are talking about the chemical signals. And semiochemicals, the Greek word just like semion is itself shown the signal. It means that is the signal triggered from the chemicals, and the chemicals mediate the interaction between the organisms. So based upon the interaction, these semiochemicals classified in two groups. One is the allelochemicals and second is the pheromones. So allelochemicals is the chemicals which works between of a different species. But pheromones here you see that is used between a single taxonomical species. So it's going to attract the same species of the pest. So just like this is the pheromones, and this is also the Greek word to carry and excite. So these pheromones I'm going to talk further. So the only one thing here to remember that is going to work in the same type of species. And there are different types of pheromones. I highlighted sex pheromones because our main target to describe here this type of pheromones. So sex pheromones attracting individuals of opposite sex, commonly used for the detect pest or in mating deception. The other types of pheromones, just like aggregation pheromones, so it helps to make a colony altogether. Here I saw one small picture. I don't know it's clear, but you see that one man totally covered with the honeybees, and you can also sometimes they show in the TV or something that they put the pheromones here and all the honeybees because of that aggregation pheromones they cover the whole body. So the main principle behind that is the aggregation pheromones. Second is the trail pheromone. Sometimes we see that the ants just moving in the one straight line. Sometimes at the childhood we play that we put the finger in their line and they didn't move because we wipe off the that chemicals what they already spread on the path. So they make the trail pheromones. That is also the part of the pheromones. Alarm pheromones. The example of this in the especially the honeybee. You maybe know that when honeybee sting one person and there are number of people there, they sting only that person what the first honeybee sting. So when the honeybee sting the first person, after stinging, their one chemicals release, and that alarm to the group of the other members of the colony. So they only attack on that person. So that is also the principle behind that stinging. That's called the alarm pheromones. There are also those like marking pheromones, that is the parasitic insects. I'm not going in the details. Anti-aggregation, epidactic. But the main thing here I'm going to discuss about the sex pheromones, how we can use in the field, the IPM, and how it's help in the agriculture. So just like I told that chemical signals that carries a message between the conspecific, which means the same species, that is the insect sex pheromones, and it's released by the exocrine glands. So in the moths, it's released from the end of abdomen, and just like ant and bees, is released from the glands or on mandibles. These are the very volatiles. The main important parameter of these pheromones is the very volatile, and it's going to proceed by the olfactory sensilla. So these are the antenna you can see, and how fine there are some sensilla here. You can see the in the details that these are the sensillas in the last picture, and very fine structures. They catch the molecules in the environment. Uh, so this depend upon the how big the antenna insects have. So mainly all the testing have been happen on the Bombyx mori, that is a silkworm moth. They have the very big sensilla, the antenna. So you can see that what is the chemistry behind that. So very small sensilla is going to take the molecules from the environment released by the female and then go for the mating and egg laying. And there are some non-volatile pheromones also, just like in the ants. You saw that they go in the trail and or something. But there are some non-volatile. They also deposited on the surface, and it's perceived by the gustatory sensilla on antenna. Is also called the tarsi in cherry fruit fly. Here the history I talked in the beginning that the number. a lot of points here, but I'm going to only focus what is the major milestone. So the first one that J. Ray suggested that the scent of female moth attracts male. He found in 1690. So it's very old findings, but nowadays it's very dominant in the agriculture field. But it had been observed in 1690, and Peter Colson and Martin Luther, they coined the term pheromones in 1959. And here you can see the small picture in the right hand side. This is the picture how we which the picture of the instrument which we used to check the effectiveness of the pheromones, and how we decide okay which pheromones we can use in the field. So they put one antenna here and they release the pheromones molecules, and that going to detect by the detector, and we see the uh, effectiveness that how much antenna receives the signals. So that is called the electroantenogram, is EAG. This is the main instrument. Still, we are using that one to detect the pheromones electrically and see that which pheromones have the most effective uh, nature on that. In 1959, the Adolf Bittendat he isolate and characterize the first insect pheromones. I told that the domestic silkworm moth, uh, that is the first insect, and he isolated and characterized by the instrument. Then Morton Biroja, these are the very famous name in the field of pheromones. If you go in the details, you usually hear the name of these scientists. So that's why I highlighted also. So Martin Biroja is the United States Department of Agriculture chemist, and he report to how can you use the sex pheromones to disrupt the insect mating. So that part I'm going to describe later, how we can use different types of practices for these pheromones we can use in the agriculture field of agriculture. There are other lists here, but I'm not going one by one. Uh, in 1970, John Kennedy he develops the wind tunnel assay. So this is the technology still we use to check the effectiveness of the pheromones. That however, so they have the wind tunnel assay. I'm not going in the details how they do, but this test they always perform to check the sensitivity of the pheromones. This is called the wind tunnel assay. And then I'll go. So this is the chemistry. I want to little bit focus on the chemistry because my background also from the chemistry. Uh, the pheromones is the hundred of the insect species have been chemically elucidated. So more than 400 insect pheromones already isolated, characterized, and we are also using in the IPM. And most pheromone consist of blends of two or more chemicals which need to emit by exactly the right proportional. This is a very important criteria characteristic in the pheromone, that is the right proportion. So only single pheromones usually is not going to work. They always have the combination of two or more pheromone molecules, but it should be in the right ratio. Even the very small change is going to dysfunction the pheromones the activity. Suppose 98 is to 2 ratio is going to change in 97 is to 3. It's totally changed. You cannot catch any, you cannot control any pest. So the right proportion is very important to be biologically active of the pheromones. Pheromones are usually mixture of several components in precise ratio that I already described. And here the SAR, that is the structure activity relationship is called, where the species specific is obtained by variation of double bond position. So you can see the chiral molecule or double bond position, and which form the isomeric forms. You hear the cis and trans or G and E. That is also play a very important role in the pheromone chemistry. So just like in general, the pheromones are the saturated and unsaturated hydrocarbons, generally with the acetate or aldehyde, alcohol, and there are different types of the molecules, just like polonic hydrocarbon, methyl branch hydrocarbons. They're mainly found in the Lepidoptera and Coleoptera. And epoxides and ketones, they're mainly in the Coleoptera also. Terpenes in the beetles, terpenoids in some paralids, and the urinoids in just like aphid and alkaloids in the Scarabidae family of the pest. So here the pheromones, the main important is the right proportion. That is very important. Here the some structure of the molecules, the pheromone molecules. I take a picture just like Bombex mori, that is silkworm, and this you can see that's very simple compound, only carbon, hydrogen. You see there are no other molecule in the structure, carbon, hydrogen, and oxygen. So this is just like alcohol group here. So that the name is just like EG, that is the isomer, and 10, 11, 10, and 12. You can say that 10 means that okay, the 10 position they have the double bond, and also the 12 position they have the double bond. So that's a 10 and 12. And hexadecane di one all. Hexadecane means hexa means 6, and decane means 10. So this a total carbon number here is 10 plus 6 is 16. So if you count, you can find this is 16 carbon chain. That's why the name assigned. So the same thing for each and every molecule. So you see, just like it's not very complicated structure, very straightforward, uh, but it's affect a lot in the pheromones chemistry. So there are some common pheromones structure you can see. I'm not going one by one, but very straight chain compound is some double bonds and oxygen and hydrogen. That's all. Again, the characteristic of the insect sex pheromones. So the best thing in the pheromone technology that very small amount you can see just like even the 10 to the minus 18 gram of the pheromones is sufficient to initiate the biological activity in the insect. So very minute the quantity is going to trigger the signal released from female in the male. And very high species specificity, the best thing in the pheromone that they only attract the same species, so there is no harm for the other insects. Just like nowadays a lot of burning topic, the pollinators, you heard on the news that most of the chemical pesticide they're killing the pollinators. That is a very burning topic nowadays. So this is a very good tool that they're not going to attract any other insect, only the same the pest species they are going to attract. So this is very good controlling. They're not going to affect any adverse effect on the other insects. And existence of very strong structure activity relationship, that is called the SAR. So if any small change going to happen is not going to affect, that's like going to inhibit the effectiveness of the pheromones. So that is also very important point. And also the best thing is they attract males or females from very long distance. You can see just like 50 to 100 meters, sometimes from miles. So also depend upon the antenna, how big antenna they have and how many sensilla on the antenna. So that perceive the pheromone molecules from the females and then go towards the female for mating and egg laying and start the fertilization. So here the one example that some chemistry the analysis part I very superficial I want to show that the one insect is called the heavy helicoverpa armigera, pink ball worm, and this is the female moth. You can see the this is the pheromone gland. You can see the red arrow. So in the practically we take that pheromone gland, we cut the gland, and we extracted the n-hexane, because this pheromone, this insect have the two uh, molecules in the pheromone. So Z11 hexadecanol and Z9. So you see there is not much difference, only Z11 and Z9. So one you have the just like the C double bond at the 11 point, 11 number of carbon, and in the second only in the 9 number of carbon. That is only difference, but the ratio always should be 98 is to 2. So we have to confirm by instrument that what is the ratio. So we extracted with the n-hexene, and why we take the n-hexene, because it's very long chain. You can see the long chain carbon, so it's also not very hydrophilic. So it's the hydrophobic. So we can extract with the non-porous solvent is n-hexene, and the best instrument to analyze the pheromones is GC, gas chromatograph, because it's very volatile compounds. I told in the beginning, so it's very easy to analyze by the gas chromatograph because they have the temperature. And here you see, I described that mainly they have the carbon, hydrogen, and oxygen. So for that type of molecule, FID, this flame ionization detector, is very good because everything going to burn and they are going to give the signal in FID. And here the one chromatogram, the GC chromatogram you can see, and this is the peak of the Z11 and this is the Z9. And if you need the unknown, suppose you don't know what the molecule, then we can go for the GCMS for the mass identification. And one sentence written at the bottom that NMR of the stereoisomerism. So stereoisomerism, that's like the isomerism we can only confirm by the NMR. Z and E or Z and Z is you cannot confirm by the GCFID. Only going to give the two separate peaks. But if you want to see the isomer, you must go by the nuclear magnetic resonance instrument. Here the main application of the insect pheromones. How many types we can use these pheromones? Yeah, first is the monitoring, second is the mass trapping, and third is the mating disruption. So monitoring of the pesticide, we can use the pheromones, and it's called the as a sex lures. So the pheromones are impregnated on the carrier, and you can put in the field, and you can see that how many male moths is coming to attract with the pheromone molecules, the pheromone source, and you can detect okay what is the population right now in the field. So that is just like for monitoring, and which is going to tell that when and where we can use the other control measures, just like when if you see just like very small amount is trapping or is coming towards the lure, it means is there no more not many population of the insects. So that time I think is at least you can take a judgment, okay, it's not good time to spray the chemicals. So that's why it's fall in the IPM. So based upon these results we can decide that how we can use the chemical pesticide in the field if you want. And here also just like field tests have shown the rough estimates of the population of the pest in the field can be made from the catches that I already described. So this is only for the monitoring. At least you can use the first point. And second, the mass trapping. You can also use these pheromones to trap the males. Here the one trap you can see here, and this is very old picture, but the same type of trap they used. So this is also the direct method for pest eradication by pheromone traps. Adults of the insects can be suppressed that manage to survive, and this technique also you can use by for the monitoring. But based upon you can put number of traps in the field based upon the distance decided by the agriculture scientist that what should be the and distance between two traps and how many traps in one plot. So you use the trash lure pheromone lure here, and male come here and then fell in the this bag, and then you can easily take the bag and eradicate the pest. So the best thing, they are going to attract only the same species of the uh, insect which trap you put here. They are not going to affect any other insect, so that is the best thing. And this type of the pheromone trap is called the ICRISAT standard pest pheromone traps. There are other also number of different traps. I will describe later, but here I want to show just one picture that how we can eradicate the pest, and pheromones can be used as a mass trapping. So mass trapping also called just like lure and kill. The pheromone traps, they lure the insect and then is going to trap in the this polythene bag, and then you can kill. So mass trapping also lure and kill principle here. And here the pheromone traps. Uh, what is called the pheromones can be used as a bait to attract certain moths and catch them in a trap. Pheromone traps are very useful for monitoring and specific pest species and will often detect low population density, but sometimes can also used for controlling that I already described. The efficiency of the traps depend partially on the mobility of the insect. Therefore, traps are usually more effective in the catching adult insects because adult can smell and they can come from very long distance. So it's easy to capture the adult because they can also fly and go towards the source. So easy to catch the adult, just like moths. And there are some common pheromone traps. It's called the delta traps, wing traps, diamond traps. That I'm going to describe in my next slide. I think. Yeah. So here see the different types of traps. Some are just like delta trap, like triangle, wing trap, panel trap, vapor trap, bucket trap, and equisette trap. I already described earlier. So everything just like we can put the pheromones here. There's just like sheet sticky trap. You can put some pheromones, spray on that, and insect moth going to lure. And when they come here, they stick on the that trap here. And same thing, bucket trap. This also similar to the Ecrisset standard. So they put the pheromone lure here, and when the moth come, they fell in the this bucket. So this is some common examples. And the third is the mating disruption. So if you have just like a large field, not only just like wheat or rice, but if you have just like horticultural crops, this technique is very useful because you cannot hang, you cannot put the pheromone traps in each and every twig on the tree. So they just like spray the pheromone mix the compound all over the tree. So when the actual female they release the pheromones to attract the males for the mating, the male confused that where is the female because we already spray the pheromones all over on the tree. So it's very hard to find to male to reach to the female for the mating and egg laying. So they just wandering here and there, and they didn't get the chance to mate, and the population going to be down. But this technique is very good for the horticultural crop, especially the trees. And betting deception used in the three strategic, just like confusion, trail masking, false trail masking. So confusion, I already described that when you spray, they don't know that from where is coming the pheromones. So it totally confuse male and they cannot mate with the female, and the pest population decreased because of that. Trail masking, sometimes we use the synthetic pheromones to destroy the pheromone trail laid by the females. So just like making the another route to show to the male, okay, the female is here, but actually there are no female. So you confuse, and uh, their lifespan is very short, the moths. So if you didn't get enough time to mate, then they self died, and there's no more population uh, for the pests. The false trail following. So when we spray the pheromones on the tree, and the same thing, they don't know where is the female, and seems like the trail is a different, the false, and they didn't get the exact path to reach to the female. So all over just like confusing and trail masking and false trail following, everything just like we confuse to the males because we sprayed pheromones all over the tree, and they don't know where the actually the female is ready for mating. So here the one picture. So you see that female is releasing and it give the exact path. So The male moth is going there. But if you put all these pheromones on the tree, you see the different paths. So female, the male confused that which path I have to follow to reach to the females. So that is the mating disruption, and they confuse that which is the exact path. So they didn't. So they are unable to mate, and the population is going to decrease. The advantage of pheromones is a lot. That's why people nowadays focusing on that pheromones. It's extremely specific because I told that is only going to affect the same species. So there are no harm to the beneficial species, just like honeybee and also some parasites, insects, and very low effective dose in the very minute quantity. I told that 10 to the minus 18 gram is very low quantity, is all going to affect, and we can use that quantity in the field, and it's very safe to the applicator, to the farmers, because there are no chemicals, everything from the natural product, you can say. There is no residue or persistence in the environment. That is also very burning topic with the chemical pesticides. That's why they want to test any chemical pesticide in the environment, that how they are behaving, which type of that molecules is forming, is toxic or non-toxic, and there are no secondary pest background because this is very safe and only works with the same insect species, and very less application, that the first point, and no specialized equipment needed. You saw that very just like simple traps we can use. There are no just like a sprayer or something, not a special technique, and resistance less likely because we are using for the same insect, and slow or prevent pesticide resistance because this is natural and we are using for the same insect, so this also slow down the pesticide resistance. So global market is going very high because most of the people now looking for the organic farming. You saw that organic fruits and vegetables now in the market, and now people are preferring because it's free of the chemicals. So for this is also very good for use in organic farming because there are no this is totally natural chemicals. There are no effect on the health and other things. And the global market very high, is going from 15.3% from 2019 to going to 5.7 billion by 2025. So very good opportunity nowadays to enter in this market. And these are the major companies who are working in the field of pheromones. I highlighted some which are very renowned nowadays. Probably this in the California, US, and also Sutera and ISCA, Tracing Corporation. But you can see a lot of companies here on the list. You can see, so it's very good opportunity. Regulation wise, because it comes under the biopesticide and pollution prevention division, and EPA told that because this is coming from the nature, so it's very safe. There is no risk, reduced risk pesticide of lower risk than conventional pesticide. So there are no more regulatory requirements. Very minor regulatory requirement if you compare the other pesticides, the chemical pesticide. So you can say they have waiver to register this project. Also, I have one the link, the EPA. So pheromone regulatory relief, they have that there because of the natural origin. There no much data required for registration of this type of pheromones in the regulatory field. Same thing here, the OECD dossier guidance. So all the regulatory guidance, they told that okay, there is no more need for any data because this come from the nature and go in the nature, environmentally friendly. So not of testing required for this. So that's all, and I acknowledge my thanks to the management of Dolphin Institute of Biomedical and Natural Sciences for giving me opportunity to give this small presentation. Thank you all, and also I'd like to thank Dr. Pandey and Arnab also to help me to set up this presentation from US and everything. Hope everything going well and everything very clear. So that's all from my side. If any questions, I'm happy to answer. So let me know. Thank you. Any question, comments?
Uh, Good afternoon, dear students. If you have any questions, then please put it in chat box. Sir will surely answer that one.
Okay, I didn't see any question here, but you can contact me if you have any question later. You can just shoot me email. I can reply.
So now Dr. Praveen has already given the presentation for the pheromones. Now, any question is there, then it could be asked in the public chat. For that, we are waiting. If questions are there, then we will communicate to Praveen ji, and then it could be responded.
Okay, I didn't see any question. Even you have letter, find any question, just shoot me email. I can reply.
Okay,
Okay.
so we have not received a question. Now I request to my colleague Mr. Upen Dwivedi for vote of thanks to Mr. Upen Dwivedi.
Thank you so much, sir. Honorable Chairman, Sir Shri Arvind Gupta ji and respected Dr. Praveen Dubey, Global R&D Metabolism Scientist, FMC Stein Research Center, Newark, Delaware, USA, and all the participants. It is a great honor for me to propose vote of thanks to all those learned personalities who have witnessed it as a memorable and successful webinar on insect sex pheromone, an important tool in IPM today. I, on my behalf and on behalf of organizing committee, extend a very hearty vote of thanks to Dr. Praveen Dubey for delivering highly valuable lecture and interactive session to all of us. You have explained in detail about the insect sex pheromone and its uses in integrated pest management. Sir, in spite of your extremely busy schedule, you readily and happily agreed to such short request and took our valuable time out of your busy schedule, sharing with participants extremely important information and practical understanding of insect sex pheromone in IPM. I'm sure students must have been benefited immensely. I must mention our deep sense of appreciation to you. Thank you so much, sir. I also to express my gratitude to Dr. Shailja Pant, Principal of the Institute, Dr. Arun Kumar, Director of the Institute, Mr. Vinod Nagpalji, Sunil Kaulji, Director, Joint Director, Mr. Vipul Goyal, Dean Dolphin Institute, Dr. C.S. Pandey, HOD of Agriculture Department, Mr. Arnab Khanda, Anuj Gupta sir, and our different faculties of our department. And but last but not the least, Mr. Sujit TK sir and his team for all-time technical and untiring support in organizing this webinar. I am very grateful to Sherwin Gupta, Chairman DIBMS, for giving us an opportunity to organize this webinar. I heartily congratulate all participants for their interest and response with their active participation in this webinar. As no program can be successful with a single person, so I extend my big thanks to agriculture faculties, big thanks to all our volunteers, thanks to all those who contributed in this event directly or indirectly. Thank you, one and all. Hope have you enjoyed this session. Have a wonderful and joyful day. Thank you so much.
Thank you. Thanks.